One of the things my office does is we work with the external partners, what they need and where they plan to go, particularly from a research perspective, and we'll partner them with the right individuals within the university here, and then work with the various funding programs that are out there, figure out what tools we should use when, and we can help them tap into some of the external funding. They get to work with a lot of students, and the students that are working on these projects are typically very, very keen, they're very, very driven, and they love working on these projects because it gives them real-world experience, and in many cases the students get hired by the company after they graduate because it turns into, say, a 6-month job interview.
MedMira develops, manufactures, and commercializes rapid diagnostic tests. Our tests are effective, but they can also always be easier for people to use and provide different types of readouts. And so we were searching around to try to find collaborators, and we were very fortunate to find an excellent researcher here at St. Mary's University with the skills and the expertise that we needed to advance our rapid diagnostics. The project results are still at their early phases, but they're really delivering really positive results for our company. And so our strategy has been to be able to bring forward a test that used to be visually interpreted and have an instrument read it. If an instrument reads a result, it's able to digitize that and send it wirelessly to be able to send them to the healthcare teams that need them and also to the patient. And so that's the long-term goal of the outputs from Dr. Brosseau.
My research is in the field of nanotechnology, so I'm interested in how light interacts with material that's at the nanoscale, and particularly metals. So we work a lot with silver nanoparticles, gold nanoparticles, and we're looking at the unique optical and electronic properties that occur because these materials have dimensions that are smaller than the wavelength of incident light. We use these particles for for next generation sensing. I work in a field known as surface-enhanced Raman spectroscopy, which is a mouthful and very specialized. But it turned out that MedMira was really interested in this particular technology. So I was really able to apply my expertise and the expertise of my students to try and solve their industry problem, which was integrating this SIRS technology with their already patented rapid vertical flow technology. And so it helps in terms of not only building the skill set of my students, but also allowing them to interact with relevant samples, samples that are more relevant to clinical samples, and also allows us to get in some new equipment and train on that equipment as well. One of the things about chemistry, it's hard sometimes for the students to really see how this is at all applicable in real life situations, but this is a great example where the student knows that what she's doing is absolutely relevant to something that may help many millions of people in the future.